So hello and welcome to this video on the quicksort algorithm. In this video I will go over the basics of quicksort as well as all the necessary steps needed to perform a quicksort. And finally I will end this video with a demonstration. So on to the basics of quicksort. So with a quicksort you have these two key concepts, which are pivots and partitions. So let's say you had a list containing elements in, let's say, unknown order, and you wanted to use a quicksort. So when you do the quicksort, you would take any one of the elements in the list and pick one of them as your pivot. And what this pivot does is it partitions the list into two sublists, one larger upper sublist and one smaller lower sublist. And quicksort algorithm guarantees that after you do that, your pivot will be in the correct position. However, you cannot make that same guarantee with the elements in the two sublists. So you will have to recursively perform quicksort algorithms until you finally arrive at your fully sorted list. So up top I have my unsorted list containing integer values in no particular order. And of these values, I take the middle position, number 7, as my pivot. And after going through the quicksort algorithm one time, I find that my number 7 is conveniently in the middle, and these values here are all less than pivot, and these values are all greater than pivot. And since these values in the lower sublist and upper sublist are not in order, I will have to use recursion. So here I have that same unsorted list, and here I did the quicksort algorithm once, and now I know that my pivot is in the correct spot, so I can just leave that there, and after that I can use the quicksort algorithm again and recursively do that, so on and so forth, until I either get elements list of size 1, and eventually I'd arrive at a fully sorted list looking like that would look like this. So yeah, and here in this text file I created a string made of randomized characters. Now like quicksort, oftentimes you see quicksort examples using only pure integer values, but it doesn't have to be like that. So long as you can make the comparisons less than and greater than, there should be no reason why you can't do a quicksort. So here these are my randomized characters, and below that I have their character values in ASCII code. And again, I do the same procedure, and I take my pivot somewhere in the middle, and this time I took it at character S. So now that I begin doing the quicksort, I would first exchange my pivot with the first element in my list. So I would swap my character S with the first element, which is the yen symbol here. So now that's done, I would also have to be concerned of two other things: small index and current. Small index keeps track of the last element in your lower sublist, and current is the same. Current in other data structures is just used to iterate through the unsorted list. So yeah, and now I begin my sort by initializing small index and current to pivot. And now, first of all, I would increment my current to the next element, 185. And here I make comparison is 185 less than pivot. That's not true, so I keep going. And same comparison check again is 164 less than pivot. Again, that's also not true, so I keep going and going until I arrive at character 67. And character 67, it's less than pivot. So what I would do is I would increment small index, which would should be here, with to up to the next element, character 185, and I'd swap the two. So now that I've done that, you notice that my lower sublist grows by 1. And here, current I incremented it from 185 to character 41. And again, this is less than pivot, so I increment small index to character 164, and I swap. So now my lower sublist grows by size 1 again. And after that, I increment current to the end of my list. And because current's at the end of the list, I'm done with comparisons. So what I would do is I'd swap my pivot with the last element pointed to by small index. So I would have, here pivot pointing at 115. I'd swap it with small index. So now my lower sublist is now sorted. And okay, so now I don't have to worry about my upper sublist, which has characters 165 through 192. And again, I pick my pivot at the middle. So in this case, it's character 133. And again, swap pivot with the first element. So there. Now that I've done that, I would to run the comparisons check. And in this case, because none of these values are less than pivot, pivot would trade places with itself, which wouldn't change anything. So I can consider my pivot as sorted. And so now on this portion of the list, I would again do the same procedure. I'd take pivot in the middle, and I'd swap pivot with the first character in the list. So there I go. Pivot's now pointing to correct position. And but in this case, okay, what you notice is that actually you need to go back, but because all the elements 165 through 164, they're all less than pivot, and so I'd increment small index and swap, but that would produce no change. So I would move my current index all the way to character 192, and then I would have swapped a small index by small index with the last element pointed to